Greetings everyone, Pawan speaking here. Welcome to my YouTube channel. In this YouTube channel, in this video, I am going to explain about multi-stage countercurrent extraction and how to draw its operating lines. Now, coming into this extraction, here we can see in the process where F is the feed and RMP is the final final raffinate quantity which is coming from the NPS stage, and whereas here S is the solvent which is sent from the end stage, and E1 is the extract that is product coming from the first stage itself. This is how the counter current works. And coming into its material balance, through its material balance, we get the following equations, that is xm1 is f into xf plus s into ys by f plus s, and delta r is, is f minus e1 and rnp minus s. Now I'll show you how to plot this on a graph. Coming to the graph, um, we'll have a x-axis and y-axis. Um, Here on x-axis we have percentage solvent, uh, that is percentage B, and here we have percentage C, that is solute, percentage C, that is solute, and we have the extract and raffinate curves. Um, Here there is an raffinate curve, and here there is an extract curve. Now let's plot this. Now we'll consider the XF. I will plot this XF on the y-axis as its percentage of solute P, which will mark it as F. And the S quantity of S, normally we take pure solvent, so it will be on x-axis, and we'll plot here S. Now I'll mark that as F and S. This is F and this is S. And now coming to the next step, always in this extraction process we will know the final product concentration, that is RNP. We'll know the XNP, which will plot on this raffinate curve. This is RNP. um, Now we will join the FS line, and using this expression, all this based on the data given in data, all these data will be given, that is F, S and XF. These data will be given in the question. Therefore, we will plot that. We'll find this XM1 and plot that on graph as I'll show now. XM1 will be somewhere here, and we will join it to the FS line. And here we get as the M. Now we will have also have an equilibrium curve where we will draw um, percentage C in raffinate and percentage percentage C in extract. We will have some curve like this, and using this equilibrium curve, we will just estimate it estimate the values of E1 and R1 such that they follow this E1, E1 and R1 will follow such that they will be on the equilibrium curve and they will pass through the M. Means this is uh, E1 and this is R1. And this E1 and R1 should pass through M. And as I will show now. To find this exact line, we have to do couple of trials, but normally we will approximate it uh, to come like this, such a way that it passes through M, and we have E1 here and R1 here. Now, as we know this operating line equation, now we will draw delta R on this curve, like by extending F and E1. We'll extend F and E1 continuously. And now similarly, next R and P and S also will, yes. Now here we have our delta R. Now as we see in this F minus E1, R and P minus S is also equal to the difference between R1 and E2, R2 and E3, R3 and E4. Similarly, like this, it's equal. Therefore, each R1, we will extend R1 to delta R and hence we'll find E2. Here, R1 minus E2 is also equal to delta R in the same logic. It's just a material balance equation. Using that logic, we will join R1, we'll extend R1 to delta R. Yeah. Now on the equilibrium curve, on the exact curve, we get E2 here. This is E2. Now, similarly, we will plot this E2 on this equilibrium curve. We will get R2, E2, and we'll get R2. Sorry for the, it doesn't look neat, but hope you'll understand. We will plot E2 here on y-axis and hence we'll get R2 here on the x-axis. And that R2 will mark here, somewhere here it will come. And now we will join, similarly we'll join, uh, and this is R2. This is another operating line, R2 and E2. Yes, this we get through equilibrium curve. And now similarly, we'll join R2 and delta R, and here we'll get R3, and similarly the continues as our required ENP. We will get we should keep on continuing this and hence get number of stages in counter current multi-stage extraction, and that's it. This is the way we draw operating line for counter current extraction. Thank you.